Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is called Surrounded Regions. Rating is medium. As we go through this, you'll probably notice if you saw the previous video, which was called, I think, Number of Islands, that it's very much like Number of Islands. So we are given an M by N matrix called board, containing the letters X and O. And our mission is to capture the regions that are surrounded. The instructions here are puzzling to me. I've read them, a number of times, and I think I understand them well enough, at least now, to work on the problem. But cells are connected to adjacent cells either horizontally or vertically. In other words, not diagonally. All right. What is a region? Well, regions are formed by O's. This is connect every O cell. Again, this is not a great example, but a region. So these three O's here, can I highlight those? No, but these three O's, this, that's a region. This O down here, that's not connected to this because it's diagonal. So really the only region in here is that L-shaped region with the three O's. A region is surrounded with X cells if you can connect the region with X cells and none of the, if you can connect the region with X cells and none of the region cells are on the edge of the board. Okay. That's really the key point here, even though to me it's really hard to understand, the region, if you can connect the region with X cells. Region cells, okay. Region cells on the edge of the board are not part of a region. Okay? So like this O here on the edge of the board, that is not part of any region. Region cell on the edge of the board is not part of any region, and any O cells that are connected horizontally or vertically to a cell on the edge of the board, that is also not part of a region. Okay. So you can maybe see where we're going with this. On the a surrounded region is captured by replacing all O's with X's in the input matrix board, meaning we have this 1 3-cell region of O's, and in the output they have been converted to X's. Okay, so in the number of islands, what we looked for were cells with a 1, and then we did a depth first search to find all the cells that were connected to the 1. And, we did that recursively. And we replaced, every time we found one, we replaced it with a 0. All the cells were 1s and 0s. So if we found a cell either we found it by traversing the matrix, or we found it by doing a depth first search, we flipped it to a 0, so we wouldn't count it a second time. Okay, so that worked fine. In this one, it just takes a little bit more. It takes a little bit more code. Okay, what we're looking for in this one is we're looking for O's. We're not looking for 1s. I mean, the analogy is we're looking for O's on the edge of the board. We're going to find O's on the edge of the board. We're going to do a depth first search. We're going to find any O's that are connected to that O. And again, we're going to do it recursively. If we find one that's connected, we'll try to find O's connected to that one. It's a little bit harder, though, because we can't just flip the O's to X's. It's possible that the output is going to still have O's in it. So we can't just go through and flip all the O's to X's. But we got to flip the O's to something. So in this case, the only thing that we're going to find when we look for O's on the edge of the board is this one O right here. Well, actually, let's do it like over here. This one O right here. And we're going to flip it. You can flip it to anything you want as long as it's not an O or an X. I'm going to flip it to a dot. All right? Once we've done that, we can take one more traversal through the array, and anything that is a, if we get to a cell and it's a dot, we'll flip it to an O, or flip it back to an O. And if we find a cell that is an O, we'll flip it to an X. And so that should work, I think. Let's see what an implementation would look like. All right, I'm going to say that a lot of this is going to be so close to what we did in number of islands that we can probably borrow some of the code here. So we define class variables in order to, one, not have to keep doing like grid.length and not have to pass the grid to the depth first search method. So, all right, we'll grab that, we'll go over here, add the class variables, char grid, numRows, numCalls. Okay, actually, in this one they call it board. So let's call it board. Okay. Let's go back over here. And we'll set the class variables. Okay. Think about this. No, I think it's fine. Okay, yeah, we'll copy that, go over here, we'll put this here. Okay, so this dot board equals board. numRows is board.length. I put this in here last time because I thought I was fixing something, but I don't think we really need it. numCalls equals board 0.length, length of the first row. All the rows are the same size. So rectangular matrix. All right. What's next? Okay. Wait a second. Oh, you know what? I think I cut that by mistake. I didn't really want to cut it. Okay, we have int island equals 0. We have no analogous thing for that, so we don't need int island, but we need the for loop. And this doesn't actually return anything. It's just it just updates the board, which is passed in as a variable, and so when it goes back, it'll be available to the calling method. All right, over here, and we need the for loop. Oh no! Oh, don't tell me. Okay. Messed up the copy. Go here, up one, paste it. All right, 4. Int I is less than num rows, int j if this dot grid equals 1. Yeah, that is not what we want. And by the way, we don't need to increment islands for this. We're not looking for ones. We are looking for O's on the edge of the board. So, how do we do that? Well, first of all, I has to either equal 0 or I has to equal num rows minus 1. This is going to get kind of long. Let's try this. Or copy that. Or j has to equal 0. Or j has to equal num calls minus 1. That whole thing should probably be in parentheses. Okay. We'll say and board ij equals O. Okay? And if it does, then we'll do the depth first search. Now, there's more to do here than there was in the other one, but we can still, I think, use the depth first search almost like as is. So let's go down here and grab it. I'll come back over here. Where is the end of the method? End of the method is here. We'll put this here. We have private void depth first search. All right. So before we start applying a row and column, because we're going to call this recursively, and it's possible as we're doing a depth first search that we're going to get to the edge of the matrix and potentially go off the edge of the matrix. So before we start applying indexes to the matrix, let's make sure that the index is actually on the board. So we can say if a row is less than 0 or row equals num rows, that means it's too big, or column is less than 0 or column is equal to num calls, and that's too big. If that's the case, we're just going to return. We're off the board. All right. Next, if the grid is not equal to the character O, we don't care. All right, that's the end of the depth first search because we're just looking for connected O's. Okay, return. So now, if we get here, then row and column are in range. The cell is an O, and we're going to flip it to a dot. Okay, and then do recursive depth first calls to the cells that are adjacent. Row, see, row plus 1, so that's down. Row minus 1 is up. Column plus 1 is right. Column minus 1 is left. So 4 connected cells. All right, good. Now, yesterday we were done. Today we're not quite done because we got to take one more pass through the array, flip the dots back to O's, and flip the O's to X's. So let's actually we can probably borrow this part of the for loop here. I 0, j is 0 if board I j equals a dot. Then flip it back to an O. Okay. Else, I don't really like it there. Else, if, I'm going to borrow this again. If board ij equals O. Grab this. We're going to change it to an X. And if we've closed everything, which we haven't, all right, so we got to close the for loop. We got to close the next for loop. I think we've closed everything now. All right. Let's try and run this. Compile error. Parentheses expected on line 16. If and oh yeah. I put a parentheses in there. Okay, we got to close that. Okay, go again. Compile error. Uh-oh. Oh, I said grid. I copied it from yesterday and I said grid. Okay, 38. This is not grid anymore. Yesterday it was grid. Today it's board. Okay? Good. Let's try it again. Wrong answer. Oh my gosh. Hang on. Okay, so I think I mentioned this before, that I've thought about, doing everything and making sure that it works perfectly ahead of time, but I feel like that just doesn't present, there's a semicolon here for absolutely no reason. But I think it presents a misleading view of programming, like somebody just sits down and types something in and it always works the first time, as opposed to making mistakes and fixing them. So, all right, let's try it one more time. I think it was calling depth first search on absolutely everything, which is not what we want. Because that semicolon was there and it shouldn't have been there. Okay, so that is accepted on the basic cases. Let's submit it, see what happens. Later. Well, we're pretty good on the runtime. I mean, there's like kind of a mini bell-shaped curve here. A few people were a little better. A few people were, a little bit slower. But that is the solution for, I can never remember the names, surrounded regions. And hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.